This video is going to have a lot of moving parts. We are going to walk through the process of getting a web page interface to communicate with an IoT Arduino device. Now, as far as I know, you cannot have a JavaScript HTML page communicate directly with an Arduino. So we're going to use a small Node.js server that's going to sit in the middle and help pass messages back and forth. So the full process will be an HTML JavaScript web page using Socket to communicate with Node.js, and then Node.js will use the serialport package to communicate with the Arduino. So to start, let's create a basic Arduino circuit. All it's going to entail is a potentiometer attached to an analog port on Arduino, and then we're going to add some code that basically takes the status of that potentiometer and passes that back to Node.js. Our first step is to attach our potentiometer to our breadboard. We're going to attach the left side of our dial to our 5-volt output. We're going to attach the right side to our ground. And finally, we're going to attach the other side to our analog port, and we'll just use analog 2. Now this will look slightly different from the circuit diagram on Tinkercad. The diagram on Tinkercad has the middle port on the same side as the other two. So just notice that my green wire is attached on the other side, whereas on the Tinkercad circuit, it would be attached in here. I'm going to use the online Arduino editor to write our code. So I've created a file here called Arduino to Node. And this file is basically going to monitor the status of our potentiometer and pass that on to our Node.js server. So to start, I'm going to create a variable called %, set it to 0, create a second variable called previous %, and set that to 0. % is going to store the current status of our potentiometer, and previous % is going to store the status that it was the last time it checked. That way we only need to pass on the status of our potentiometer to our Node.js server if a change has happened. If the current status is different than the status was the last time we checked, then we pass it on to Node.js. So in our setup, all we need to do is get our serial port connected. And in our loop, we are going to take our % variable and calculate a nice clean percentage of the potentiometer in its current state. So I'm going to take the current status. I'm going to read port 2. I'm going to divide that by 1024. That is the current, the full range of our potentiometer, and then I'm going to multiply that by 100 just to get a nice clean percentage. Then we're going to check to see, is the % different than it was last time we checked? And if they are different, we'll pass it on. So we'll take our serial port, use the print line function, and pass on our new percentage. Then I'm going to take the current percentage and place it into our previous % variable so we can use that to check next loop. And finally, we don't want this running as fast as it can, so we'll put a 100 millisecond delay on our loop. Then we can connect our Arduino. And once that's connected, we should see our board right here. I'm going to click over to my monitor. Any information that is written to our serial port will show up here. And let's upload our new code. Great, so I have an error. Just spelled serial wrong. So we will try that again. No errors this time, so that looks good. Right, and now if I turn my dial, we get our percentage. So there it is all the way up and all the way down. Our next step is to get our Node.js server communicating with our Arduino. So to do that, I need to install the Node package serialport, and I want version 9.0.1. Then I can just do an npm install and download our serial package. Next, create a file called app.js. In this file, all we're going to do for now is have this file listen to the serial port and console.log anything that it receives. So, create a new variable, call it serialport, and we will load in our serialport library. Next, we need to create what's called a parser. And using our parser, we need to tell Node.js how to receive data coming in through the serial port. And in our case, we want it to receive data anytime it receives a new line. And the delimiter for a new line is /r/n. Next, we want to open up a port. Now, when we open up a port, we need to specify the location of our port. You can find the location using your command line, and there are instructions in the GitHub repository. Or you can go back to your online editor, and inside the dropdown, you'll notice there is my Arduino board. And this strange string of characters here, on a Mac, it usually starts with dev. On a PC, it'll have the word com in there somewhere. We want to copy that and paste that in here. Next, we just need to specify a bunch of settings. Okay, and I just forgot a bracket up here. Now we want to attach our port to our parsers object. Lastly, we want to take our parser and add an onData event. So when our parser receives data, it's going to run this function. Any data it receives will be placed into this data argument. So for now, let's just console.log whatever data we receive. So I'm going to save that and start my app. Okay, so we have an error here. So we have an error here, and what it's saying is that this resource is busy, and what it's referring to is that the serial port is currently in use. So you may not have this error, but if you do, go back to your online Arduino editor, and if you have the monitor open, it is using the serial port, so it won't allow a second application to also use that serial port. So make sure we close that monitor. You can do that just by going back to your Sketchbook tab. If you're using the offline editor, same thing, just close that monitor. Then go back to your Node.js file, and we will restart it. And now at this point we have no errors. So go back to your dial on your Arduino, and as I turn, you can see that that dial status is getting from our Arduino to our Node.js server. For the next step, we're going to create the web page, the front end. All this is going to do for now is create a basic HTML page and have a place where we can display the current status of our potentiometer. So if you haven't already, create a new file and call it index.html. And let's add in our basic HTML tag requirements. And in our head section, we need to include the socket library. So I've already copied the CDN URL, so I'm going to paste that in there. And then in our body section, and for now, let's create a div and give it the ID sample. We are going to be receiving a message using the socket library. So I'm going to create a variable called socket. And I'm going to take that socket variable and listen for an event called data. And when the data event happens, we are going to run this function. And for now, let's just log whatever data we are receiving. And place that data into our sample div. So I'm going to save that file. Now let's go back to our app.js, and we need to get a server up and running. So let's create a basic server. Again, let's not use any external libraries for this. We'll just use the built-in HTTP library, the file system library to grab our index page, and let's just go ahead and grab our index right now. Then let's create a server. So I'm going to call it app. And this server will return a 200 response code and the contents of our index.html file. So if I save that and run my Node app, no error, so that looks good. And then open up my local host, and there is my web page. Now at this point, if I turn my dial, nothing on my web page happens. So I want to go back here. Notice we're still receiving data from our Arduino. So now I want to include socket, and when that data comes in from our Arduino, we want to pass it on to the browser using socket. So go back to your package.json file, and we're just going to add another dependency. We want to include socket, and we want version 2.04. So save that. Do an npm install. All right, go back to our app.json. And right here, let's initialize socket. Oh, and sorry, this has to go after we initialize our app because I want to connect socket to our app. And then on our socket variable, we're going to wait for the connection event, and when the connection happens, let's just console.log Node.js is listening. Okay, and then when we receive data from our parser, that is data coming from the serial port, we want to emit a message. That message is called data, and the data we want to pass is this data variable. Right, now we want to take this code here, and I'm just going to move it to below our IO connection setup. Okay, we need to do that because we don't want to reference IO, a variable that was only defined here. Okay, I'm going to start my app again. Okay, this time I have an error. Oh, and this one here, sorry, that should be listen, not apply. So save that and try again. Okay, no errors this time. Let's go back to our browser and refresh. Go back to our Node.js, and notice we now have someone listening. That is our front end. And if I turn my dial, there's a couple numbers. And now if I go back to my browser, I should be seeing a number here. So let's inspect element. Open up our console, and we're getting an error on our get element by ID. So go back to our HTML, and this should be inner HTML. Save that. Clear that. Restart our app. Go back to my browser and refresh. Okay, no errors this time. And if I turn my dial, sorry, this is not a function, this is a property. So we want to change that to inner HTML equals data. Save that again. Restart our Node app. Okay, and then back to our browser, refresh. And one more time, let's try our dial here. There we go. So you can see there is our number. So that number is successfully being transmitted from our Arduino to our Node.js server and then to our browser. The last piece I want to add here is if we go back to our HTML, instead of just displaying that data, let's make something visual. So I'm just going to add here a couple styles. And I'm just going to take my sample. I'm just going to make it a box. And give it a background color of red. Okay, and now this time, instead of changing the inner HTML, I want to change the opacity equal to data. Now, data at this point is a number from 0 to 100. So I'm just going to divide it by 100 because opacity is set using 0 to 1. So now if I clear this, restart my app, go back to my browser, and refresh. And now as I turn my dial, we can turn my div on and off.